Most people understand multimodal search as searching by text and sometimes by image, but you can also search by individual documents. We built an application using the dataset from the National Portrait Gallery in order to build a live exploratory application that lets you curate your own image board of all of the portraits from the museum. Let's dive into how we built it, what it is, why we built it, and enabling you to create your own in the Mixpeak platform. So let's dive into it. At its core, what it is it's an image board that has already been indexed in a Mixpeak collection. And so what we do is we can click any individual portrait, click the magnifying glass, and it does effectively a reverse search on that portrait against the collection. And so we can curate our own feed of different visuals that have similar properties. So we can also do text-based querying. So dog outside. We get that result here. So again, we can combine the text search with a reverse document search. And so now we have dog outside as the query, and we're combining that with this reverse document search. And then there's more. We can also combine text search with image search. So I should have a picture of my dog on my desktop here. So let's take a look. We got Aussie here. So we have a picture of a dog, and we do that reverse image search. It takes a little bit longer because it's processing the image. So we get the result here. So this is the closest image in this collection of 120,000 images. And so we can say, hey, we want this dog image, but blue, right? So it's combining these two queries. And so we don't actually have any blue dogs. Maybe we could do red. Maybe there's a closer one there. So it might just not be in the collection. And so we are combining text plus image, and we can also combine the actual document reference. And so this query itself is saying, hey, combine this image with this text, with this document reference in order to find the most relevant result that combines all three of them using hybrid search, right? So let's dive into how we built it. We're using the image extractor namespace in the Mixpeak namespace, and it is using Google SigLIP 768 dimensions. And so it is in our image galleries namespace, and we created a bucket. That bucket has a bunch of properties. The main property is really just image. And so this just means whenever we upload an object to this bucket, it has to contain that image. It has to contain an image here. And so we've uploaded, in this case, 118,000 images, totaling 12 gigs. And we've already created the batch and submitted the batch. But it's a single batch that has been processed, and it has run through the entire object set. And so then we just take a look at what that processing does. We've got the portrait gallery bucket, and it is processing through this collection. The collection is creating a bunch of documents under the hood, and those documents all contain 768 dimension vector embedding, as well as all of the metadata values from the objects. So we can see some of those metadata values if we click the information icon. We got a bunch of properties specific to the portrait gallery's object when we did the ingestion. And so we're just passing them in, and we can see if we click this, we get the actual page from the National Gallery of Art on that piece of art. So we go back here, we can say we've got our collection. Again, the collection has a feature URI. Feature URI maps the embedding model, maps the vector configuration, etc. And so then what we do is we build this retriever, and the retriever, say dog outside, and the retriever is a multi-stage pipeline. In this case, it's just one stage. We just have feature search. And the feature search is 3 different concurrent searches. So the very first one is a text-based search. Actually, real quick, let's showcase the actual retriever schema. So when we created our retriever, we are providing the retriever schema. So this is the input schema. So whenever we execute the retriever, we have to pass if they're required, we have to pass them into the actual retriever when we execute the retriever. And so in this case, we have 3 inputs: text, image, and document reference. Document reference is really just when we're clicking that magnifying glass. When we're clicking that magnifying glass, we're using that document reference search. So we're getting those similar documents based off of that reference. So we have text, image, and document reference. And so in the actual stage, we are saying each of these, if none are provided, then skip them, right? And so that allows us to actually, when we are first running the query and we don't have any inputs, to skipping them and maybe even doing a random. we can optionally do random to generate random vectors, or skip or error. So this allows you to construct your own retriever pipeline given these n number of queries in the same feature search. And so we're passing in from the retriever input schema, we're passing in text into this query, we're passing image into this query, and we're passing document reference into this query. And as we can see, the document reference accepts a collection ID as well as a document ID. So each of these has their own top K as well as a final top K. And so we're just using the default reciprocal rank fusion properties, but we can optionally configure weights that are specific to each of these queries in this single feature search pipeline. And so in this case, we are just doing a single feature search, but we can combine this feature search with other stages like LLM filtering, API lookup if we wanted to use the national gallery of our API, web search, etc. So we can combine them all into a single retriever pipeline. And so again, when we run this query, we get those results. And each of these, we are actually able to capture signals. So we can capture a download signal, capture a bookmark signal, etc. And those signals are then stored in our interactions table. And this is important because the interactions table, assuming we have a good set of interactions and signals, we can use them to do a learned re-rank step. And so that allows us to actually modify the results based off interactions and user properties, et cetera. And so this allows us to build a recommendation system using the signals from our users combined with the content. So this is how TikTok, Netflix, Instagram all builds recommendation systems. It combines the user metadata with the content embeddings in order to create what's called a two-tower architecture in order to find what is most relevant given certain user properties and certain content. So we'll have a deeper dive discussion on that in a later video. And so you could see all of this if you wanted to build it yourself in the Mixpeak showcase GitHub. So we can see we've got a download NGA script as well as an ingest Mixpeak script. And so everything is standalone. All you need is an API key and a namespace, and you can start uploading files, start retrieving files, etc. And so this is just one namespace, one example, and we have the full write-up in the blog. With the full write-up in the blog, so you can see here we've got Visual Search RRF is the blog post slug. And we have a full breakdown from a technical standpoint of how everything works, why we chose the models, why we chose the architecture, why we chose the retriever stages in order to support the actual use case that we wanted, which is an exploratory multimodal search application. So users can kind of explore visuals, explore properties, explore text, image, etc., in order to build a feed that is relevant to them. And so if you wanted to build this, if you wanted to build other sorts of retrieval-based applications, check it out. It's mixpeak.com. The actual demo application is mxp.co/r/npg. We'll give a link to that in the video description. And my name is Ethan. Thank you.